Hello friends, welcome to Aquaponic Live and I am Chandrakant. Last week we had a very good discussion about some engineering products, especially about the industrial cable with the CEO of Toshnibal Cables, Mr. Naveen Toshnibal. So Naveen is back in our show today and he will show us some more interesting items from his industry. So without further ado, let's welcome Naveen.
Hello, Chandrakant. I hope all is well and look forward to another session with you.
All is well. I think our viewers would like to know more about the industrial cable. I think last week we discussed about the thermocouple and we had some questions. But today we are very eagerly waiting what next you will show in terms of the offerings from your company to our viewers.
You see, now I will show you some few more variety of samples and explain the technical aspects. So that will give an idea what sort of products we are making. Uh, See, now last week we had discussed about thermocouple cables. Now you see this one. I hope you can see this. This is a three-core cable. Three-core cables are normally used for connecting RTDs. RTDs is Resistance Temperature Detector. This is another instrument which measures temperature, just like a thermocouple. And the cable which is used to connect RTD is normally a three-core cable like this. And this is called a RTD cable. Now, this is having a conductor here, which has got copper strands, and then you have the insulation on this, which can be of PVC or any other material as required at the site. And then we have got one shielding over here, which is a taped aluminum foil. It is a combination of polyester and aluminum, and it is a metallic tape with an insulation on the top of polyester. And this is the earthing wire. We call it the drain wire, this one. This drain wire is used for earthing this a metallic portion of the tape to the ground. The purpose of this is to prevent or reduce the electrostatic interferences which may be coming from the nearby electrical or high voltage or high current cables, because any signal which is going inside this RTD cable will distort the signal. So this shielding is a must for these specialized cables which are carrying very few millivolts. So this is a three-core cable, as I said, with a shielding for electrostatic, for reducing the electrostatic interference. Then there is another feature you will see. This is the armor. Armor is basically made of wires, and this is made of GI, galvanized iron, and it is used for providing mechanical strength to the cable. So if the cable is laid in a place where there are chances of people stamping on it, or there is a chance of mechanical disturbance or mechanical pressure on the cables, then this armor is essential. So you will see that there is a sheath of PVC before the armor, which gives the base for putting the armor. And then this is the final sheathing of the cable, which finishes the entire construction. So again, as I'm telling, I told you earlier also, these are all made to specific requirements of the clients or the end user. Now, there may be cases where armor may not be required, so the cable will finish here. And there are places where electrostatic interference may not be there. So then this shielding portion can be eliminated. So again, the conductor size inside, this can vary depending on the end user application. It can be 1.5 square mm or even 1 square mm, 0.75 square mm, even lower or even higher as per the client requirement. So this is just in brief about an RTD cable.
Naveen, can you also tell our viewers where this RTD cable is used and what are its application? what type of industries it is used for?
See, as I mentioned earlier, RTD means resistance temperature detector. So it is used for connecting RTD to the place where you are measuring the temperature, maybe in the control rooms. So the application can be in any industry. Wherever RTDs are there, we have to use the RTD cables for extending the RTD to the measuring place. So it is used in any industry. It can be steel plants, power plants, refineries, fertilizers, cement. Any industry will be using these RTDs, and in turn they will be requiring RTD cables for extension.
And any industry can be using this. And you also mentioned about the shielding. So again, it is very, very generic for all industries, or it is specific to only certain applications and industries?
See, mostly we will recommend to take a shielding to avoid or reduce the electrostatic interference. But then again, it will be customer or end user specific. If they really require the shielding, if they don't have any power cables or any other interferences nearby, then shielding may not be required, but we will always recommend to go in for the shielding so that it provides a very good signal when we are measuring the temperature through the RTDs.
Uh, Naveen I also wanted to ask you one very generic question, and that is about the fiber optics. And nowadays, fiber optics is also being used extensively for carrying these signals, etc., and these parameters. Um, how the fiber optics is different from the cables that you are manufacturing? Is there any basic difference?
See, fiber optic is a totally different technology, but as you rightly said, it is a cable which is very commonly used in the communication sector. See, or whatever these Airtel and Tata, they are offering these internet connections, they will be having these fiber optic cables. The technology is totally different. There, the signals are actually carried through a glass fiber and through the concept of total internal reflection. See, you must have studied in your school and college days. There is a concept of total internal reflection where if you are passing a light wave through a glass, and if the angle of incidence is actually more than the refractive index, something like that, then it is not going out of the glass. It is actually reflecting back, and it is bouncing inside the fiber only, so that there is no signal loss whatsoever. So it's a totally different technology as compared to the copper cables which I use in the industry, and these are mostly used for communication purposes, and the signal loss in such fiber optic cables is almost zero.
And that was one of the reasons that I asked you this question, because the cost of manufacturing fiber optics cable is almost very, very negligible. You know, the raw material is available in earth, and you don't need to create a very fine glass. Because of the internal reflection, the fiber optics can carry your light signals. So, do you see any applications where you convert the thermocouple readings before transmitting that through a fiber cable without requiring the copper RTD cable? Do you see that kind of future emerging in this area?
See, as per my knowledge, I think thermocouple cable or RTD cable are much different from a communication cable which is using fiber optic technology, because fiber optic cables are mostly used in communication industry, and even today in most of the core sectors like steel, power, cement, whatever, refineries, they are still preferring to go with the conventional copper cables. I don't know about the future because I'm not an expert in the application. We are experts in the manufacturing part, but I don't think there is any reduction of demand for these cables.
Yeah, I thought it is important to also tell the viewers the basic difference between RTD and the fiber optics and how they are different. What else you want to show our viewers today, Naveen?
Yeah, I'll show you another sample which will give you some idea. Now, see, we were talking about RTD cables. See, now this is, I am showing a close up. This is again a multi-triad cable. Triad means three, a bunch of three. So you will see there are 9 such bunches of threes. So in fact, there are, yeah, like, yeah, okay. So, right. So you will see there are 9 triads in this. 9 triads means total 27 core in bunches of three. So in fact, this cable can be used to connect 9 RTDs at a time. And the cable carrying the 9 individual RTDs are put in this common cable. So the conductor size here is quite thick, maybe as per the client requirement, it is probably 2.5 square mm. And you will see that each triad is having shielding on this. Each triad is shielded because each triad shielding or each pair shielding is required wherever cable is carrying analog signals. If the cable is carrying digital signals, then this individual shielding may not be required. Only this overall shielding, the overall shielding with the drain wire, this one is sufficient in case of digital signals. Even in the individual triads, you will find that there is a, drain wire, but it is inside. You are not able to see it from here. Then again, the other parameters like the inner sheath, then the armor and the outer sheath. This again come as per client's requirement. Now you see here the type of armor is slightly different. The earlier one which I showed you, this had a round type armor, and this is having a strip type armor, flat armor. This flat armor is used for thicker, bigger cables like this. So this is as per the relevant Indian and international standards. So this will give you an idea how a multi-triad cable looks like. This is a single triad RTD cable, and this is a multi-triad RTD cable with each pair overall shielding and also an armor for mechanical protection.
One question I have, a very layman type of a question, which is like once the industry is being set up, then the people will require your cable, etc., to lay down in their factories and their workshops, etc. How often we need to replace these cables, or what is the type of life these cables have? Do you have any information on that or some data points on that which you can share today?
See, normally it it will depend on the site application, what is the condition or atmosphere of the site, and it will also depend on the type of insulations we are using on the cable. But in general, I have seen that if we supply a good quality cable, nothing happens to it for the 7 8 years or something. Commercial term of course says that there is a warranty of 12 months from commissioning or 18 months from the dispatch, but practically speaking the cable will run without any problem. If the site conditions are not very unfavorable, it should run for 7 8 years at a stretch. It should not give any problem.
Excellent, Naveenji. In fact, I have one question which is personally my own confusion, and that is in case there is a very long cable, and especially the cable is carrying the indication, it's basically carrying some information which you can, decode at other end. Now, something goes wrong in a cable which is like, say, 1 kilometer long. How would people know that this cable has been broken at this place? And if it is broken, do you need to replace the entire cable, or you can fix the problem in that area and then carry on with the cable? What happens in this scenario?
See, if there is a breakage, of course, chances of breakage in between is very, very rare case, because if you give multi-stranded conductors, all the five, six, or seven strands which are used for making a conductor will not break at a time at one place. So the continuity will always be there. But in case there is a breakage or something like this happens, there are fault detectors which will help you to detect at what length the fault is there. And of course, there are ways and means of repairing it also. It is a very technical process, but it is possible, and the facilities are there in our factory to detect the faults. In fact, even during the manufacturing process, we may have some faults, and the fault detector is actually very helpful to know exactly where the fault is, so that we can locate that spot and then do the necessary rectification or repair on that particular point.
I think, Naveenji, it was a very fruitful discussion today we had, and we learned so many new things. Even though this is a simple stuff like cable, but how much technology that goes behind building something like this, and how much knowledge you must have, how much knowledge the people working in your enterprise must have, and their qualification. I think that shows the importance of this particular thing, because a lot of people's lives depend on this. If the readings are wrong, then the boiler may explode. So things like that, it's so important. Lovely talking to you today and learning very, very interesting things today from you, Naveen.
My pleasure. It was so nice of you to ask relevant questions. And in fact, when you ask, we also refresh our memories, what we learnt in school and college.
Certainly, Naveenji, I will catch you in the next one. But for today, I like to say goodbye.